Start recording. All right, welcome to day 3 or something. All right, last week. So if you want to make a triangle spin, let's get a better pen on here. Thickness, yeah, thickness up a little bit, and let's make it, I don't know, some sort of red color. All right, so if you've got a triangle, this triangle is in screen space, and so screen space coordinates work like this, right? This is y goes down, x goes across, and then z isn't really on the screen, but it's there. And so let's say all the points on this triangle are at distance 5 from the screen, and you've got another triangle that is at distance 3. What's going to happen is, let me draw this triangle in blue maybe. The angle on this is really weird. It's like coming at this really shallow angle. Okay. So let's say the blue triangle is at distance 3. What happens when you do the rasterization, right, is that we're going through every point inside of the triangle. Technically, we're going through every point on the screen because we didn't, and by we, I mean me, didn't optimize it, right, at all. So what happens is you go through every point inside the triangle, and you figure out the color based on the barycentric coordinates. That's what we worked on the last 2 days. When you write it to the screen, you're going to be like, all right, this is, switch it back to red. You're going to write a red pixel. You're going to sort of fill in all these pixels with red. And when you write them, you also write the value of 5. So there's also a z buffer. A z buffer is a 2D array, and at every point in the array, it holds how far away that pixel is. So this pixel is going to be like 5 away or something like that. Then when you go to rasterize another triangle, you go through every point in that triangle, and let's say you get to a point that already has a z element in it, or it already has a color in it. Basically, what you do is, like if I'm going to try drawing a blue pixel here, I check the z buffer at this row, at this column, and it's like, oh, the current distance is 5. Hey, I'm only 3 away, so I'm going to draw a blue pixel there over the red pixel. And so what's going to happen is that the near triangle is going to draw over the old triangle, despite one note not wanting that to happen. Okay. And so, and then if you have another triangle and this one's 10 away, let's make this green, it's going to draw behind the other two. Because for every, this guy's 10 away, because every time it draws a pixel, it writes into the z buffer at that row, at that column, and it writes in a 10. And if it tries coming over here, it's like, oh, there's already a 5 in there. Sorry, 5 is closer than me. I'm not going to draw green. It comes over here. Oh, there's already a 3 in here. In the z buffer at that location, there's already a 3. I'm trying to do a 10. 10's further away than 3, so you don't draw it. And so that's how you can get multiple triangles to overlap each other. Now, if you want them to rotate, the important thing is to have them rotate around their center. It's very important in a 3D. Whenever you do 3D gaming or anything, all of your objects are going to have an origin, and that origin matters a lot more than the world origin. The world origin is kind of interesting, but not really interesting, because, like, at least in this case, it lets us know where the corner of the screen is, right? But in a 3D game, the world origin rarely comes up. You don't rotate things around the world origin, right? Usually. This would be a very odd thing to have it kind of circling around the center of the world, or scaling it proportional, like scaling away from the center of the world. That's a very weird thing to do. Instead, only translation is in relation to the world origin, and that kind of doesn't matter, because just wherever the origin is, it's just an offset from the origin. It doesn't really matter. So if you want to rotate it around this point, you have to have a point. And so in your triangle class is going to have an origin in it, and that point can actually be moved around. Like if you're editing like different model editors and things like that, you can actually change where the 0, 0, 0 in the local coordinate space is. And so what you want to do, if you want to rotate this red triangle around this point here, what you do is you, let's say this guy, just to make up a number, he's 20 east and 5 down or something like that. So his origin is 25, and I guess, what did we say? He was also 5 away in the z direction. So what you do, if you want to spin him around that point there, is you translate him west 20, up 5, and that's going to put the triangle, I'll draw it in red, it's going to put the triangle here, centered on the world origin. Then you do the rotation that we talked about yesterday, that equation, and it's going to spin. So it'll spin, and then maybe you end up with a triangle that looks like this or something. And then you translate it back. You translate it back 5 and back 20, and at the end of the day, you end up with a triangle that was here originally and is now somebody keeps entering and joining the video chat. Now it's been rotated there around its center point. So what you do every frame is you clear the screen, you clear the Z buffer, because the Z buffer data is going to get invalidated every time you move something. Row 5, column 20. Yeah, that is the column, that is the row. So you translate it over the origin, you rotate it, and you translate it back, and that's how you do the math on it. And that thing will sit there and spin. If every frame you rotate it a little bit, it'll sit there and spin in place. And there's equations for spinning it around the z-axis, which is what we're doing here. So it's just going to spin like a 2D spin. But you can spin it around the x-axis, you can spin it around the y-axis, and create all sorts of cool 3D effects and things like that. You get super confused. Yeah, so x is the column, right? And y is the row. So that's always important, because sometimes, like in curses, it's yx. Like they always do y first, then x, because we're used to talking about row then columns. And so like it'll be like print w. I can't write. This tablet's not really set up right on here. It'd be like they have a function called print w yx, and so it prints to a window at this y at this x. And so in curses they just always do y first. I typically do x first, I guess. I don't know. It's just I'm just used to doing x, y, z instead of y, x, z. So spinning donut written in C. That's cool. I thought this inspired the homework. No, I've never seen that before. It looks cool though. Okay. So yeah. So that's your homework. So make 3 triangles. Just have vertex buffers, separate vertex. Like you could have them share points, I guess, but that'd be kind of weird. Just have them so you're gonna have 9 different points of your vertex buffer, and then just make a rotate function on it. So every triangle is gonna need a origin, which is the center point on it. It doesn't have to be the center point. If you put the origin here, then when you did a rotation, it would rotate around this way, all right? Or you could rotate it counterclockwise that way. So wherever you put the center point, that's the place where it's going to rotate from. That's where it's going to scale from. If you put the center point here, then the thing would kind of slide around that way, you know. Okay. So you're going to have 3 points defining the vertices, the edges of the triangle, and then you're going to have 1 point holding the center of it. And then just make a rotate function. Rotatos. And yep, and then every frame you're going to clear. Step 1, you're going to clear the screen. If we wanted to be super cool, we do double buffering. The colors library doesn't support double buffering. It's something I actually want to add because it actually exists. Like it's not something that I did. You know, like it's. Terminals have supported double buffering for a long time, so you can write to 1 buffer and then switch the buffers, so that way you don't see it draw in real time. So you clear the screen, clear the Z buffer, and then you're going to rotate each triangle. And the code that Buzikin posted yesterday has code for rotating around Z, code for rotating around X, code for rotating around Y. Do all three if you want. It's cool. You can add like a, maybe you could add like a, in addition to a rotate function, you could add and you need a center point as well on it. But maybe you can also add like an angular velocity. That's kind of cool. So every frame it updates based on the angular velocity times the delta. Remember that. Always figure out delta t, how long it's been since the last frame. Otherwise, a faster system will spin faster, right? So you always want to normalize it using delta t. So the amount that you move is always going to be your velocity times the change in time. So if you have a higher frame rate or a lower frame rate, the thing still moves or still spins at the same speed. So you're going to clear the screen, you're going to clear the Z buffer, you're going to rotate each triangle, and then you are going to raster each triangle, and that's it. That's your assignment. Okay. So move origin, rotate 3 points, move back to world position. Yeah. So that's your rotate function. This is your main loop here. That is your main loop. That's really weird looking M. And for your rotate function here, this thing is going to be translate to origin, rotate using rotate each point, and then around the origin, that's the equation. You can use Muia's matrix code. He has a pretty nice matrix library, I think. Muia, you support like linear operations like vertex times matrix, and you might even want to just hard code in rotate, things like that. Rotate each point around the origin and then translate back. That's your assignment. That'll be due tomorrow. Okay, I'll screenshot that for you. Not too bad. I'd like for you guys to get started early on that, just because I'm sure at some point you're going to get stuck, and that's normal. But one of the reasons why I'm doing this is just so you guys get comfortable with working with the linear algebra side of things and understanding how rasterization works, because I've been talking about rasterization for a long time in this class without giving you guys an assignment to do it. And the way that you learn things is by actually doing it. So this will give you hands-on experience doing a simple renderer with like 3D motion in it and stuff like that. And it's kind of cool too, I think. It's kind of cool because among other things, it'll be used as the welcome window for new students. Okay. Welcome to the matrix. If you want, you can add motion so the triangles fly around the screen, rotating. I don't know, could be cool. Make snowflakes, because technically this is a 3D renderer that we have, and so you can build using your vertex mesh. If you think about it, you could actually make like a snowflake. Maybe 4 triangles makes a pyramid, right? And you get 4 pyramids together, and then you can spin those around and have them scaling, and or you can just do the basic assignment. That's fine too. Yeah, this is actually a working 3D renderer. So it's a 3D engine that works inside of a terminal, which is crazy. Yeah, the matrix, right? I don't think that the putty people expected people to write 3D renderers for a terminal interface, but you know what? It's pretty cool. So, and one thing you might also want to try doing is turning the resolution up on putty. So if you and then you maybe even have like the vertex buffer be based on the terminal size or something like that. So like the size of the triangles is actually based on like how big the screen is. Because if you so there's a 4K image rendered inside of a terminal, right? But if you were to reduce the font size, you increase your resolution. And so if you turn the font size actually down to 1, then you actually get 1 pixel per character, and you actually get pixel perfect rendering inside of Putty. And so if you were to make a 3D renderer at font size of 1, it's actually as high detailed as your screen. You can see I could probably add some anti-aliasing and things like that in here. But yeah, it's pretty good. Yeah, it's a 4K image rendering inside of, maybe it's not 4K. No, it's a high res. Maybe it's 1080p. That makes sense. It's a full full photograph rendering, fairly high quality inside of Putty, right? And so if I scroll down here, watch Putty start barfing as it tries scrolling this image. It is not designed for scrolling high res images around. If I mouse wheel up or something like it. I've had Putty crash on me before. I submitted a bug report to them, and I never heard back. I'm like, hey man, when I'm trying to render a 4K image inside of Putty, it's really slow. It crashes sometimes. Never heard back from them. It's kind of weird. Okay, so yeah, so if you want to make it more professional, then have it actually get the size of the screen. You already know how to do that. We've done that several times. Get terminal size, and it returns rows and columns. And so you can actually make your triangles proportional to the size of the screen. So it doesn't matter if they're low res, high res. The triangles are the same size, and then you can have them fly around and I don't know, form seesaw at 4x or something like that. I don't know. I'll give you guys lots of extra credit if you make it nice. Or you can just do 3 spinning triangles. Either way, it's all good. Okay, so that's it for today, guys. I know you got to go, Benninghoven. Sorry that the earlier part was helping Muia debug, but that linear algebra stuff is actually 50B in a nutshell. So, and the bug that Muia came up with, for those of you at home, we discovered a bug that was caused by C++ optimizing away the copy constructor. And so he really needed his copy constructor to be called because it was clearing a flag. When it made a copy, it would clear something. And the copy constructor was getting elided, which means that thing wasn't getting cleared when it should have been getting cleared. And so working around that was, discovering that was one thing, like trying to figure out why it wasn't being called. Going through and figuring out, okay, is the default constructor getting called? What's going on here? And like sort of zooming in on the problem, finding the problem, and then realizing the solution, which is to disable copy elision, which is a really rough solution, actually caused another bug because he was returning a copy. And so, yeah, we had to go about the solution in a completely different way. It was a very interesting bug to track down. So thanks to Muia for that, and he's working on a linear algebra library for, I guess you guys, but I guess for everyone or something, that can do matrix multiplication and matrix times vector and all that kind of stuff for you guys. But you don't need it for this assignment. You got your own 3D renderer ready to go. Okay, so that's it for today, guys. Debug the debug. Yeah, that was an interesting bug. It's one of the, I thought it would just be something simple that he was doing, but it was actually tricky. All right, peace out, you guys. See you tomorrow, and I hope to see your flying triangles then. Yeah. All right, see you. Oh, Aaron, if you have any questions, Aaron, I'll hang out here for a little bit. Okay.